Okay, so I can't show you guys the code until the end of the practice session. It's in your best interest to figure out how to do it for yourself. You know, I think that's the right principle to have. Actually, you know what? I want to help you guys out. I'm going to show you the Rust code. Who wants to see some Rust code to solve the parcels problem? Alright, so in the previous video I did a bit of a whiteboard drawing of how this all works and how to go about solving the problem. And now I'm just going to quickly take you through the code that actually solves it. So we've got some Rust code here, so it's going to be quick. And we represent our diamonds with a struct which has the leftmost point and the rightmost point. So it's like a square rotated 45 degrees, huh? And so we can create a new diamond just by taking the ij coordinate, which is within the matrix of delivery outposts. And we also have a radius or a distance to the nearest outpost, which kind of determines the size of the diamond. And here we just converting to diagonal coordinates. So it's kind of like we're using a grid that's, instead of an x and a y-axis, our x and y-axis are both rotated 45 degrees. And one thing that's a bit weird about that is we get points that line up with the original grid, I and j. But later on, once we do intersections, we may also get points that are kind of halfway between two lattice points. So like we can get like 2.5 instead of just having 2 and 3. We could get halfway between. We get 2.5 coordinate or something like that. And that, although it's a valid point within our new coordinate system, it's not a valid place to build a new outpost. So we just have to be careful with that later on. And that was the tricky edge case that we'll get to. So we have some code for intersecting. So we have some code for intersecting the diamonds, and we help ourselves out by returning an optional diamond because there's a chance that there is no intersection, so there is no such thing as an intersection. And Rust will force us to check if it is a valid diamond or not. So this helps us prevent bugs by using an option. Really, really, really good. Rather than returning null, returning an option. Because then you can get null pointer errors. And this is just a shrink method, which shrinks the intersected diamond by 1. And that's useful for when we want to try to improve the overall distance. So we decrease the distance by 1. So the diamond each edge wants to go towards the furthest away outpost that kind of was responsible for creating that edge in the original intersection. So that's a little bit of a tricky thing to think about, but it's critical to the solution. And then this isDegenerate method just checks that the left side is not to the right of the right hand side, because that means it's no longer got a positive area. And then got a breadth first search method, which takes a grid and the number of rows and the number of columns, and it just loops through. Well, it starts off with all of the delivery outposts, so they're all of the cells that have some distance 0 from a delivery outpost. And then we just go through all the children of the ij coordinate, so the up, left, down, right kind of thing. And if that cell hasn't been set yet, then we set it to be 1 higher than the current distance, which we've got from our vec dequeue. So this is an order 1 operation, so this is super quick. So you can think of it as it's a queue. So to the left of the queue will be all of the 0 distance cells, and then we're adding all the 1 distance cells and then all the 2 distance cells and so on. So it's always increasing. So we go through all the 0s and add all the 1s, and then we go through all the 1s and add the 2s and so on until we get a maximum distance. So here's our solve solution. So we've just got a vector of optional distances. And we've got the rows and columns, which is the size of this grid. So we just breadth first search and we make it mutable, which means this grid is getting updated in place. And so now every cell will have a distance. And then to get the maximum distance, we're just iterating over all of the rows. So that's just the item will be a vector of optional usize. And then we flatten that, which just combines all of those values from all the different vectors into one. So now we've got all of the cells, so all the optional usizes, and then we flatten that again to get the usizes, because an optional value, it's either null or it's a value that's iterable. So when you iterate an optional value, either you get the value or you get nothing, an empty kind of iterator. So that's quite powerful. And so now we've got these usizes, and then we just unwrap. We take the maximum and we just unwrap it because we know that it's there. And there's always at least one delivery outpost. And then we just do some bucket sorting, which basically means for every distance we have a bucket of all the coordinates of that distance. And now we look at the maximum distance and we just pop off a coordinate of maximum distance, and that gives us our starting diamond, which is like the current diamond. And the idea is we'll just keep going through all the coordinates from highest distance to lowest distance, and each time we'll just create a diamond and intersect it with the current diamond. So you can see we're just going from 1 up until and this equals means we're including the maximum distance, but we're reversing that. So we're taking the distances in reverse order, and so now we're getting all the coordinates of that distance in this loop here. And yeah, so create a new diamond, and if there's an intersection, then we just make the current diamond equal to the intersection. If there's not an intersection, then we just return the distance, because we know that the other diamond didn't intersect, and so that delivery outpost can't get helped by adding a delivery outpost to our current intersection, and so D will be the answer. Okay, so now once we've gone through all of the diamonds of that distance, then this is the edge case, which is quite tricky, where we only have, if our left is equal to our right, then our diamond is radius 0, and so it's just a single point in the grid, and so we can make a delivery outpost there, and which means the answer will be D minus 1, because everything of that distance is satisfied. But the problem is, if this singular cell is not valid in the original grid because our coordinate system is different, and like it could be cell 2.5 for example, then we have to return D, because we can't actually build a single delivery outpost there. And for that we just solve some simultaneous equations, or you could just kind of look at it and be like, A plus B has to be an even number or an odd number. But here's just the working here. So now when we originally construct a diamond from I and J, we go J minus D plus 1 minus I. And in our case, D plus 1 is just 0, because we've got a singular point, so it's just J minus I. And then here we've just got I plus J. And this is the same, because we're at the 0 point. So that just gives us these two simultaneous equations to solve, and when you solve that, plug it into here, you end up getting that 2 times I is equal to B minus A, so B minus A must be even, so we can write that as B minus A percent, I should put this in brackets actually, percent 2 should be 0. Yeah, so that was a tricky edge case. And then yeah, so if you've gone through and you've done all these intersections, and and this isn't the case, then basically we want to shrink the diamond, because we're decreasing the distance, and to decrease the distance, the each edge of the diamond has to move towards the outposts that need a lower distance. So we shrink the diamond, and if we're not able to shrink the diamond, so look, it's now degenerate, right? If it becomes degenerate, then we can't actually shrink the diamond. So then we would just, what that means is the radius of the diamond must be 0. So it's like a line. And so at that point we just add a delivery outpost somewhere in there, and we satisfy everything out within there, but then we can't lower the distance any further. But if we can shrink it, then we just go back and we take all the diamonds of the next distance down. And if we get past all the diamonds of size 1, then the answer is just going to be 0. It just means all the delivery outposts are 0. So yeah, and then here we're just reading the standard in, which is quite cool. And this grid function I made in a previous video has been quite helpful, because it just takes any function that maps a character to any value. So here we've just got a closure, which it just maps C, a character, to an optional distance. So this means if it's an outpost, a delivery outpost, then our distance is some distance of 0. Otherwise, our distance is none, because we don't know what it is yet. And I could have just used 0 or -1. -1 could represent that we don't know yet, but then that means elsewhere in my code I have to remember to check for -1. And whereas using an option, Rust will force us to kind of make sure we have a value. And so yeah, that's a preferred approach to using like a sentinel value to represent something. And the other thing is our distances are always positive as well. So if we're using a -1 number, it's kind of takes away certain capabilities. Like if you wanted to do like bit shifting, like there's all kinds of things you want it, or indexing into array. It's nice using a usize. And actually we did index into an array, because look, if at this point we tried to get a bucket from a distance, it's like we need to know that that distance is positive, otherwise it's not a valid index, right? But yeah, and yeah, to find this bug here, I basically just ran a simulation. So I generated some test cases just using this Python script. And I ran that, and yeah, this bug here, because look, here we return d-1 anyway, so most of the time it's just this happened like less than 1 in 1,000 times. Like I think I passed like a few thousand different test cases that were randomly generated, and then yeah, it just blew up compared to the brute force algorithm. And so yeah, I was able to correct this bug. But yeah, I wonder if I removed this and just submitted it, maybe I would pass all of their test cases. Who knows? But yeah, if we want to generate that, Python gen.text. So look, we got a whole lot of test cases, and I'll just show you how fast this is. And I'll time this. So yeah, 0.01 of a second, so it's pretty quick, and I'm recording a video at the same time, and I'm not charging my laptop or anything, so that's pretty damn quick. What time I figured it out, yeah, that's real quick. Anyway, so yeah, I'll link the GitHub below in the comments. And yeah, feel free to have a look through the Rust code. But yeah, I hope you enjoyed it, and good luck everyone trying to solve this problem. And yeah, obviously you don't really need to do an ON solution. I mean, our time limit is 15 seconds, so we're well under that. So you could just use binary search and, binary search on what the actual distance is, and then each time just check if it's possible with that distance or not. Might be easier to implement. But yeah, good luck, and yeah, feel free to subscribe if you like, and I'll catch you next time.